Welcome back to the classroom. My name is Mr. Wong. Today we're going to be looking at revising ionic and covalent compounds. Our lesson intention for today is to revise the features of ionic and covalent compounds. Your success criteria will be to analyze the features and naming conventions of ionic and covalent compounds. Let's begin. We first introduced the concept of ionic charge. We talked about cations and anions. Now, ions are atoms that have an electric charge. So you can see here. If you recall, the reason why ions exist is because of the atom either losing or gaining electrons. In this case, their valence shell. So, for example, with sodium, you can see a positive value here. It means it has lost one electron, while as oxygen here, it's negative, it's gained 2 electrons. The reason why it's gained 2 is because electrons are negative particles. You'll find that most cations are metals and all anions are non-metals. When it comes to trying to work out what the charge number is, we can find on our table here, in group 1, the charge number is +1, group 2, +2, 3, 4 can be plus or minus, we'll leave it as it is right now. Group 5 or 15 is -3, and then so on and so on. Group 8 has a charge of 0. That's because it has a full valence shell or full outer shell. Okay, so that's what we have here. Now, if we want to try and draw the structure, or if we want to know the amount of valence electrons available in each of these rows, it depends on group number. So number of valence electrons equals to group number. So in the case of something like carbon in group 4, it will have 4 valence electrons. While there's something like neon in group 8 will have 8 valence electrons. Just note, helium is a special case. It only has 2 valence electrons. So that's the only exception to the ruling we have so far in this table here. So, in terms of the differences between ionic and covalent bonds, ionic bonds occur because electrons are given from the metal cation and it's taken in by the non-metal anion. You can see in this case, sodium is a metal. It gives its electron to chloride and you get sodium chloride. Covalent compounds or covalent bonds are different. Electrons are shared between 2 or more non-metals. So we have 2 carbon atoms. They are sharing their atoms or sharing their electrons together. They don't form ions. You can see the main difference. The chlorine has a full valence shell by taking in that electron. This carbon and this carbon here, they actually are holding the electrons together. So this is the concept of sharing. Okay, so let's categorize these chemicals and work out whether they are ionic or whether they are covalent. I'm going to do a couple of them and then the rest I'll let you figure out yourself. So in our first example here, we have carbon and hydrogen. If you look at the positioning of the periodic table, carbon is a non-metal, hydrogen is also a non-metal, so we have a bond between 2 non-metals. That means we have a covalent compound. We already talked about sodium chloride, but we can still talk about it again. Sodium is a metal, chlorine is a non-metal. So when we have a combination of a metal plus a non-metal, we have a ionic compound. Let's try something like this one in the middle here. This is ethanoic acid. Okay. It's made of carbon, hydrogen, and oxygen. All three of these are non-metals. That means we are dealing with a covalent compound. Okay, so those are some nice examples for you there. If we talk about, aluminium sulfide, sulfur is a metalloid, so a semi-metal. Still, it follows the same convention. It would still also be a ionic compound. Okay, so and that's what we have for this response here. You can try some of these other questions as well. Okay, in order to work out which ones are metals and non-metals, nice little periodic table you have here. Hydrogen is the only exception to this, but everything on the left-hand side of the periodic table are metals. Everything on the right-hand side are non-metals. You can see shaded in blue, everything shaded in red is metals. Hydrogen is the only one that doesn't follow that particular trend because that's not how we group elements of the periodic table together. We have things like boron, silicon, germanium. These are what's known as metalloids. We also call them semi-metals, so they have properties of metals, but they are not exactly metals. They have some properties similar to non-metals as well. Okay, so the next question we want to look at is, by completing the table, name the type of ion that forms with these elements and look at the type of charge that would form when they have a cation. Let's fill in the potassium and the sulfur first. Now potassium is a metal. Keep in mind all metals will give their electrons away. In this case potassium, if it's going to give away electrons, it's going to be a cation. The next question is to work out how many electrons will it lose. Well, if we go back to this table here, sodium, or potassium, sorry, is in group 1. We already stated that in group 1, everything is plus 1. That's not a great plus 1, but plus 1. So we have plus 1 here. Okay? We can also see that with lithium, it also is plus 1. What that tells us, if it's any positive value, it means it's lost electrons, so it has to be a cation. But by looking at the charge number, we can also work out that lithium is also in the same group number, or the same column, as potassium. So you can see that with lithium up here. Alright, let's go to sulfur. Sulfur is an anion, which means it will be in the non-metals category. So if we have a look, and you might need to squint your eyes a little bit, but sulfur is over here. So in this position here. Now let's look at which group number it's in. It's in group 2, or this is group 2, sorry. We're going to skip this column box here. We're going to go 3, 4, 5, 6. So it's 6. Now we said that group 6 is -2. So it's going to lose, or sorry, it's going to gain 2 electrons. Okay, another one we can try is perhaps chlorine. Now chlorine, I know, is a non-metal. So chlorine is actually right here, and its charge number would therefore be -1. So chlorine is -1. It's a non-metal. So if it was to form an ion, it would be an anion or an anion. Okay, so there's that. Try the other ones and see what you get as a response in the worksheet as well. Alright, the final component we're going to talk about is naming covalent compounds. Okay, so just a couple of rules. Remember, when naming covalent compounds, the second letter or the second element, you always replace the last few letters with IDE at the end. So in this case, we have, in the first example, we have carbon plus oxygen. So essentially we've gotten rid of the last 4 words in this case and added IDE to give the name oxide. Now in this formula we only have one oxygen, hence why we give it the prefix monoxide. You might be wondering, therefore, why don't we give carbon the same naming? So remember, if there's only one atom, so one atom for the first element, no prefix is required. And that's an important thing to note. We can look at example 4 here. We have nitrogen, and there's 2 of them. So we're going to call it dinitrogen. What you also notice is the first word, or the first element, the left element, I guess, that doesn't experience a name change. So no name change. But we can see with oxygen here, it's going to be called oxide, and we have 3 of them, so we call it trioxide, as stated by this table here. So I'm going to go through a couple of questions in terms of the naming. You can always refer back to this table when you do your own responses as well, but let's have a look. So let's name the following compounds. Now this is not exactly covalent. This is naming ionic and covalent. Why do I say that? Because the first one we have here is a type of an ionic compound. Now with ionic compounds, the metal name always comes first. It doesn't experience a change. So here we have Ca, which is calcium. Okay. Oh, whoops. So calcium. And we have Cl. Now Cl is chlorine. So chlorine. Okay. But we need to get rid of the last few words and add IDE. So it's going to be called calcium chloride. Okay, so that's the name of this. Notice there's no prefix. So there's no prefix for ionic compounds. Keep that in mind. Only covalent compounds uses prefixes. The reason being is we can actually work out what the formula of the chemical will be just by name or just by looking at the periodic table. So this formula here, CaCl2, we can note from that calcium is a 2+ charge, chlorine is a 1-. Because remember the crisscross method, so you can actually crisscross back the other way to work out how many charge, or what's the charge value of that. Okay, let's go through another one. So we have over here phosphorus, pentachloride. So let's just write the chemicals we have first. We firstly have phosphorus. The fact that we have penta, that's a prefix, so this means that this is a covalent compound. So phosphorus chloride, let's write that there. Penta. Now, looking back at the table, if you're not sure, penta is 5 in total. So that means I have pentachloride, which means I have 5 chlorine atoms lashed onto the one phosphorus atom. let's try one more, or two more actually, and then we'll call it a day. Over here we have carbon and we have oxygen. So again, carbon first, two oxygens. Now firstly, just make sure you check whether or not this is an ionic or covalent compound. For your own sake, carbon is a non-metal, oxygen is also a non-metal. If that's the case, then we need to write a prefix for this O2. So it's di for 2 and oxide to represent the anion we formed. Last one, LiBr. Okay, so Li is a metal, it's lithium. Br is a non-metal bromine. So we're dealing with a ionic compound, which means we don't have to write any prefixes. If that's the case, we just call it lithium, and we call it bromide. And that's it. So try the rest of the questions and see what response you can get for those. Anyhow, that concludes our revision lesson for naming features of ionic and covalent compounds. Thank you for joining me today. If you enjoyed the video, give it a like, and take care, enjoy these videos some more, and continue on with your day.